I'm Dimitri. I am finishing my 5th or 6th year of grad school, depending on how you count. And I do atomic physics. Basically what that means is I shoot atoms with lasers. We talk a lot about the laws of nature and this kind of stuff, and really all of those are guesses. They're really good guesses that we can use to make really accurate predictions about things that are going to happen in the future. But it's still just a guess. And the standard model is sort of our name for our current best guess. And I can probe that by shining laser light on atoms. My family often asks me, well, why is this important? What can you use it for? And I can tell them, oh, well, some astrophysicists care about what's going on inside my lab because it helps them understand what they see with their telescopes. It helps them understand super heavy neutron stars that are millions of light years away from our solar system. But really that's not a very satisfying answer. I think what they're looking for is for me to say something like, oh, well, I can make shoes that make you run faster or something like this. Or, like, I have a new, better camera. But that's not really what I do every day in the lab. Really, the things I do, because they're on the cutting edge of what we understand about the universe, we can't possibly imagine the future applications yet because we don't even know what we're going to see. My experiment in particular has totally changed the way I view the world around me. And I don't just mean in a physics sense, but also in a physics sense. So my research in particular is precision measurement. So I'm doing really stringent tests of the standard model. And it's really important then to be able to quantify all the uncertainty in your measurement, because I'm looking for really small things and they're very hard to find, and so I spend a lot of my time thinking about and imagining things that could be wrong with my experiment, going and identifying them, checking them, and fixing them, or measuring them and subtracting their contribution from what I'm actually trying to be measuring. I spend a lot of time thinking about sources of error and uncertainty in my measurement. And it's changed my opinion about what science is and how people come to believe what science says. I find it really difficult now to interpret data that comes without error bars. Because I spend a lot of my time in the lab thinking about what are some possible sources of error, what are some things that could be happening in my lab that make it look like I'm measuring something even when I'm not. Error bars play such a big role in interpretation of data. And they've also made me a little bit of a better teacher. And this I mean that I recently started thinking about grades as if they were measurements about me. Really, what we need to be training our students to do is to interpret grades as a piece of feedback and move forward from it. Be able to change either the environment that they're studying in or change the way that they're studying, to use as feedback to improve themselves as students and persevere in science despite getting the bad grade. And I do this all the time in my lab. I mean, if I gave up every time that I realized that the thing I was measuring was really different from what I expected it to be, or really different from what I wanted, I wouldn't have made it through my first year. Instead, what I do is I sit back and I think, what is causing this to be wrong? And then I go and fix it. And I wish we could, as scientists, convince students to approach their own learning in the same way.